Hello everyone, welcome again to my part 2 of DA Server Modbus TCP in Archestra. So in part 1 what we have done is we've installed our DA server for Modbus and we have shown you in SMC what it looks like, and in this part 2 we'll try to connect it to our Modicon M580 PLC here. So just to align ourselves here, this is the SMC, Archestra System Management Console. This tool is accessible using the Windows button here, and then searching for System Management Console. If you click on it, this is what it gives you. So once you get this application going, click on the DA Server Manager, expand Default Group, Local, and you'll see your new Archestra DA Server Modbus TCP. If you expand this, it will show you your configuration. And in your configuration, this is what I use always as a default. I don't even change it at all. If there's any issues with your comms, please go ahead and change it, but I always keep it as the same. So the next thing you want to do is under configuration, there's nothing in there. You right click this guy here. You open and you create a new port for your Modbus TCP. Just give it a new name and click enter. So Modbus TCP port is always 502. The next thing you want to do is to create a Modbus slave or objects. So for the Schneider Electric Modicon M580 PLC or any other 340 PLC, they always use TSX quantum objects. You click on it. It gives you an opportunity to enter your IP address here. So I've got a Modicon control expert connected to the PLC here. So this is the control expert here. So in order to get your IP address for your PLC, you just double click on the PLC bus. It will bring you to this screen here. So double click on the port here. That's where you find your IP address of your PLC. So so that's my IP address. So I'm just going to enter my IP address 192.168. Okay. So I always keep my reply timeout and all the other stuffs as per default. You can change whichever way you want, but for Modicon PLC they always use this, right? So I wouldn't change any of this. Okay, so now you got that. So next thing you have to do is you have to give it a topic name. Right click this guy here, add, and call it M580. Okay, just keep your, and this is your polling interval for this topic. So okay, so now you got this all going. Once everything is ready to go, you right click this guy here and activate the server. Once you activate the server, you will have more diagnostic information. There you go, about that particular thing. So any tags that's being pulled will come out in a client group or information. Sorry, I forgot to save that. But any information, any tags that you're pulling will all come in here. I'll show here shortly. So next thing you want to do is launch your InTouch tool. So, and then you open your application that you want to edit. Okay, here you have your application, right, that you want to edit. So you go to tag dictionary, and then you create a new, let's create a new tag, right? Let's call it new, call ZZZ ABC, complete detail here. And this is going to be of memory type, say, I want to keep it simple. So I'm going to try to pull, say, 40,000 address 42709, right? So it's going to be called IO integer. So it's going to be 42709 or maybe 10. I'm not too sure. So 40,000 registers. This is 40,000 registers. This is your coil, right? And to read real is 40,000 register, real is this. So I'm going to go click on this one here for now, for an example. Click OK. They will ask you for address here. So first of all, you have to create a topic. You click add here. Now you're going to give an access name 580. Your node name will be localhost because you're going through the Archestra DAS Modbus driver. Your application name will be DASMBTCP. And your topic name, as you have defined in here, will be M580. Straight link and advise only active items. Just keep this as checked off. Okay. Then you will have your items in here. Close it. 580 comes in here now. So this is a Modbus address you're trying to pull. Right. So say 2708. Say for example, I want to pull that. So I don't want to scale it. Initial value is 0. Right. So once you do that, you close it. Sorry, save it first. And then you close it. Now you have a tag. Next, we'll display that tag on a window. I've got a test window here called AA test. So I'm just going to open this guy up here. We're going to use a text pound to indicate it's a number. Double click it. Click on analog. Then you go ahead and select your tag that you want, which is this one. Right. You can also select here if you don't know which tag it is. But I made a mistake here, so we'll see what this produced here. So it's 42708. Just note that for now. Say close. Okay. Okay. So before you hit save, you want to go and see your client group here. Right now it shows that it's healthy, it's pulling the PLC well, and there's no tags in here, indicating that there's nothing being pulled right now. So as soon as I save it and I run it, it will start to show all the values that's being pulled. So I'm going to hit save here. Okay, now I'm going to runtime it, this window. You can see that it's showing 0 here, and this Modbus address is in red. And if you go and look at your settings here, sorry, a log file, it does tell you that around about here, I think. Yeah, this is when we ran the program. Let's run the program, and it says illegal data address. So if you look at the World Wide Web, the user manual for that, you can actually see that when they say illegal data address, it means that the PLC address, query PLCs, I mean this is data address in the query sent to the PLC is not allowed for this PLC. So to mitigate that problem here, what you do is that you go back to your InTouch screen here, open your test again, double click this guy. You have to put a 0 here. This is 40,000 registers. So yeah, I recognize that we're trying to read 42,708, but Wonderware expects a 0 here. So if you save it now, okay, and you go back to your this group here, okay, still reading 0. You saved it, close it. You gotta save the window in order to actually get it because it's running. So what happens then when you save it, it's running. It will try to read the value from the Modbus table. So save it. As soon as you save it, this will turn green. There you go, which means it's good COM. So next what I'll do is I'll go ahead and start being able to modify this. I've got a control expert connected to a Modicon PLC M580. So I've got this a sheet to actually write the program. So what I'm gonna do is I'm gonna create a tag called ZZ test say int, right? Go ahead, integer, And then there's two ways to do this. One is either you create a move block. I'll show you a lot programming way to do it, I guess. So what I'm going to do is here first start it ZZ test 01 int, I think. Is that what I call them? No. ZZ, like that. And we're going to write to a Modbus address as defined here is 42708. Ignore the 0. This is Wonderware thing. So in order to write to a 40,000 register, you go %MW427. Just have to make sure that you have to -1, which is 07, because it's one of them is a 0 base. The Modicon PLC is a 0 base, but the Wonderware is a 1 base address. So what I mean by that is that the Wonderware's ArchestrA, the DA server starts from 1, 2, 3 all the way to 65,000 Modbus address, but the Modicon PLC starts with 0, 1, 2, 3. That's why it's always offset by 1. Sorry. So when you say MW, you don't have to put the 40,000 in the front, and then that's done. So let's do the online change on the PLC. You can see that both sides will show 0. It's because my Z init has 0 right now. So we are moving 0 into 0 here. That's why you're getting a value of 0, which you'll get by a value of 0. So if I were to go ahead and monitor this on a table here, and then I do modification, and I say change it to, let's go put it aside here. So it's showing 0 here, it's showing 0 here. So if I go ahead and put, say, we're gonna deal with whole number here. So 88, hit enter. So 88 is forced in here, 88, 88. Okay, so that's how you read an integer on the Wonderware. So if I were to go ahead and now let's try what is this window here? Oh, historian. So minimize it. Let's try reading a real value, right? So you create new ZZ, call it a real. Keep the flavor. So so we're gonna read one register up. So which is gonna be one register down, which is gonna be say 10, right? So we save. And one thing you have to know is that if you are trying, oh, I think I made a mistake here. So IO type should be IO real, because we're trying to read real, right? So over here, it's gonna have to add the word F in here. If it doesn't add F, you need to add them F. So I just want to make sure it's 2709 F, which means it's occupying 2709 and 10, but it's a 1 base though. I'll show you what I mean by that. You hit save. Okay, and you have to make sure that that the other one is not crossing over to this guy here. You gotta read it from this PLC. That's our test PLC. 27. Save. Close. Gonna verify again, make sure that is correct. So ABC is reading as 2708, and then this is reading at 2709 and 10, and it's reading from the PLC there. So close this guy here. Make a copy of it. Analog. We're just gonna call it real, so we can see decimal places on this one here. Then hit select, and then now you're gonna select your tag, this guy here. Okay. Close. Okay. And when you hit save here, what happens is that 2 register will come in. The 2708 is good, 2709 is good too. You can see that the addressing is correct, but if you had left out the 0, it will give you a red and show you error there. So anyway, everything is good. So your value is 0 right now. So we'll write a PLC program here on the Modicon. That's that test underscore real. This is wrong. Sorry, this is a monitor. We want to add the tag. That's that test underscore real. Yes, we're doing online edit real, right? And then over here, you got to do a bit of conversion and whatnot because you're dealing with two registers. So let me show you what I mean by that. So first of all, you got to take your real and then you got to change it as a word first, right? So it's going to be ZZ_task_real right here. And then it spits out two low and high Modbus addresses. It's a 32-bit register, 16-bit each. So we got to it spits out the word. So I normally do is convert the word to int. I don't think it's necessary for this one here, but it's always safe. I've seen a few cases where this doesn't work, so this has always worked for me. So over here, we join here because on the Modbus end you're expecting an int, so you convert that. So over here, since we are reading Modbus address 2709, so the first address has to be %MW 2708. Now remember, Modicon PLC starts with 0 and Modbus starts with 1. That's why you got to start with 2708. And then the second address in Wonderware, because it's a floating point, it's looking for 270910. This is going to have to be 27 MW 2709, like that. Okay, so build, and once you build, it will load the program in. Great. So let me bring the programming tool up here. So it's showing 0 right now, right? Showing 0 right now. And on this side here, it's showing 0 as well. So if I were to, let's watch this tag here. If I were to force a value of say 42.84 or whatever, hit enter, you can see that it will show 42.83 here, 42.83 here. So if I were to change this to 123.4 whatever, oops, 123 whatever number, it will change accordingly. And this guy here, it's the whole number that we're dealing with, and it changes accordingly. Now for the Boolean part, right, I'm just gonna create a Boolean program to start off with. First we create a tag, call it that, say yes, and this is gonna be a Boolean type. And over here, so Boolean is treated like a one register, so you're gonna have to use a move command. So you hit a move, click it in here. So assign ZZ task underscore BLN for Boolean. You can name whatever you want, the tag name, right? So over here, so I'm just gonna keep the same vibe. So it's gonna be M instead of MW 2707. So this is on the 2707 register. This is different. This is MW means is 42,707. Let me make it a bit bigger. This one means 42,707 MW when you say MW, but when you say M, it's only saying 2,707, right? So what I'm going to do is hit compile. What it does is that it does online download and runs the program. So right now it should be showing 0 or off or false or whatever you like. Okay, so I'm gonna go in there since it's Boolean. Gonna hit table to monitor it. Right now it's 0. Okay, which is fine. So over here, so I'm gonna go over here and then say add another tag, maybe here, somewhere here. Hit enter, double click it. So over here, I'm gonna say this time I'm gonna have to say discrete, right? So we double click this guy here. you're gonna have to create a new one. New test BLN. Give it a name. Make sure it's your PLC is that. And then over here, your address was 2707 on the Modicon, so you're gonna have to be 2708. Right? It's not 40,000, like I say. You hit save here, close, and then you can say when it's on, what message you want to say, right? Maybe say power on or something like that. Power off or anything. Let's say okay. When you hit save, what happens is that that particular register starts get polling. It's right now showing power off. Everything should be showing green, which is good, right? So now if you open your Control Expert, which is the Modicon PLC programming tool there, and then if you were to modify this to on, it should show power on, and through here off, it should show false, power off again and again, right? Well, that pretty much concludes, I guess, all the information and items that I wanted to share with you about the DA server for Modbus TCP. I hope it helps you. Please subscribe and like. Other than that, happy programming. Bye.